Hello and welcome to my channel once again after long. Today I am not going to deliver a lecture sort of thing on particular topic or topics. Rather, it is the first installment, or you can call session 1 of a series of presentations or videos, and the series name is Con-Quiz, Learning Physical Chemistry through Conceptual Quiz, Question and Answers. Of course, we have some aims: conceptual clarity, correlating diverse concepts, brainstorming, handling tricky questions, unlearning misleading questions or conceptions and misconceptions, and finally preparing for exams like JEE, BSc University Honors, IIT-JAM, CSIR-UGC NET, GATE, SET, etc. And the types of questions that I will cover: rapid fire, true false kind of questions, short answer type questions, SAQ, multiple choice questions, MCQ or multiple select questions, MSQ, and numerical answer type questions. The topics I will try to cover. The first one is general chemistry, of course a warm up session, and then to be followed by kinetic theory of gas and real gas, chemical kinetics, conductance and electrochemistry, thermodynamics, quantum mechanics and chemistry, spectroscopy, statistical thermodynamics, mathematical preliminaries, that much of maths needed for chemistry honors, and many more. So today's session 1, general chemistry, it's part 1, which is of course rapid fire, true false kind of question, and with occasional explanations in some places. So let us start. Are you ready? So I will present you the questions first. The kinetic energy of a system of several particles equals the sum of the kinetic energies of the individual particles. True or false? The same type, but potential energy of a system of interacting particles equal the sum of the potential energies of the individual particles. The SI unit of both energy and work is joule. Integration dx by x is log b by log a. Again, integration dx by x, limit a to b, is log b minus a, and x dx, the answer is half into b minus a whole square. So you can give a pause at this moment, and when you are ready you can check your answers and come back to the video. So let us give you the answer. The first one is true. Of course, the second one is false. And SI unit of both energy and work, as you know, is joule. The next one, dx by x, it is log x, but if you put the limit, it should be log b minus log a. So that means log b of b by a. So the statement is false. Similarly, the next one, again dx by x, so it is log x. After putting the limit a b, it should be ln b minus ln a, not ln b minus a. So the answer is again false, ln b by a. And the last one, x dx, the answer is x square by 2, and after putting the limit, it should be half into b square minus a square, not b minus a whole square. So this is the right answer. So hope you have checked it and got all the answers to be correct on your own. So let us go to the next slide. Again, I will present the questions first. The ratio of PV by MT is the same for all gases in the limit of 0 pressure. The next one, similar, but PV by NT, N is the number of moles, is the same for all gases in the limit of 0 pressure. All ideal gases have the same density at 25 degrees centigrade and 1 bar. All ideal gases have the same number of molecular molecules per unit volume at 25 degrees centigrade and 1 bar. 1 gram is Avogadro's number of times as heavy as 1 atomic mass unit, AMU. The Avogadro constant has no units. So give a pause. After a few seconds or minutes, we can come back to the video to check your answers. Now let me give you the answers. The first one is of course false, because in the limit of zero pressure, the gas behaves ideal, that's okay. But even for ideal gas, PV by MT is not constant. It depends on the molar mass. But the next one is by same reason is true, because now it is PV by NT, which is equal to R, constant. All ideal gases have the same density. False statement. It has the same volume, but density depends on the molar masses. So different gases have different molar masses. So it is not true. The next one is true, because now this is the number of molecules. So PV equal to nRT. So N by V, number of moles per unit volume, is P by RT. So at a given pressure and temperature, the whole right hand side is constant. Now 1 AMU. So one has to have very clear idea what 1 AMU is. It is the mass, what mass? 1/12 of the molecular mass of a single carbon atom. So 12 gram is the molar mass of 1 mole. So for a single, it is 12 by Avogadro number, and it's 1/12. So 1 by 12 into 12 by Na, that means 1 by Na gram. So what we get? 1 AMU is 1 by Na grams. If you cross multiply, so 1 gram is Na atomic mass unit. So I think it's clear to you that statement is true. And interestingly, it is a misleading conception that Avogadro constant has no unit. It has a value 6.023 into 10 to the power 23. Of course, if you say Avogadro number, then it is 6.023 into 10 to the power 23. But if you call it Avogadro constant, then it has a unit, and that is mole inverse. So henceforth, you please remember the unit of Avogadro constant. Let us go to the next slide. 1 Newton is 1 kg meter second square. So these are rather similar simple problems, but good for exercise. 1 joule is 1 kg meter square second to the power minus 2. 1 liter is 10 to the power 3 meter cube. 1 watt is 1 kg meter second to the power minus 2. Next one is all gases approach ideal behavior at sufficiently low pressure. Two gaseous systems with the same values of temperature and pressure and number of moles can have different volumes. Well, the answers. Newton, you know, force, so mass into acceleration, mass in SI is kg, and acceleration is meter second to the power minus 2. But here it is second to the power plus 2, so it is wrong. So 1 Newton is 1 kg meter second to the power minus 2. Joule. Joule is SI unit of energy or work, and that is force into displacement. So Newton into meter. Now Newton, just in the previous problem, 1 kg meter second to the power minus 2 into displacement meter. So finally it gives you 1 kg meter square second to the power minus 2, and that is given in the question. So it's the right step. 1 liter is 10 to the power 3, which is again false, because 1 liter is 1000 centimeter cube, and centimeter is 10 to the minus 2 meter. So it's cube, so 10 to the minus 2 meter whole cube. So finally the result is 10 to the minus 3, not plus 3, as given in the question. 1 watt power unit. So again it is joule per second, and joule as given in the second problem, kg meter square second to the minus 2 per second. So finally the answer is 1 kg meter square second to the power minus 3. Well, the next question. All gases approach ideal behavior at sufficiently low pressure. Yes, as we know. But the next question, again it is true. Two gaseous systems with the same values of temperature, pressure and N. So V is nRT by P. So it seems that okay, V is same for all gases, but this is only for ideal. But here the question gives you for all gases, not ideal. So for real gases, the V may not be the same, because for example, Van der Waals gas, the constants A and B depend on the nature of the gas, thus the volume would be different. I think I've got my point. So let us go to the next slide. Here two mathematical preliminary, and it's very interesting. You can play with these two games with your calculator or mobile calculator only. It tells about a summation limit x tends to 0 x to the power x. Is it equal to 1, true or false? Actually it is true, but how we can evaluate? By simply using a calculator. Let us see. Another one, the question, again a limiting problem, limit x tends to 0, 1 plus x whole to the power 1 by x. And this is a very famous number, irrational transcendental number, E. So let us see how one can check with the calculator. So we just take the calculator, you take x values of decreasing order 0.1, 0.01, 0.001 and so on, and you evaluate simply x to the power x by your calculator, and you will see that the values are increasing gradually and approaching towards 1. So in the limiting case, you can safely say, though it's not a proof, but it demonstrates that the summation is 1. Similarly, the next problem, again you take 10 to the power minus 3 minus 10 to the power minus 3. 10 to the power 4 minus 10 to the power minus 4. So oscillating value actually. 10 to the power 5 minus 10 to the power 5. And you evaluate by calculator 1 plus x whole to the power 1 by x. And then you will see that it is gradually converging to a value which is very popular with us, and that is nothing but E hat 2.7182818. So I think you will enjoy it by playing with your calculator. Well, a few more preliminaries of mathematics, mathematical convention actually. So it's a summation 2j plus 1, j goes from 0 to 4. The answer is given as 10. Let us check. We'll check it later. Another is suppose it's a sum of couple of terms, product of terms, x1 y1 plus x2 y2 plus x3 y3 plus it goes on up to xs ys. So it is sum over xj and sum over yj. In both the cases, j goes from 1 to s. So this is the question, and the last one is, it's a double summation. I is 1 to 2 and j is 4 to 6. So first it takes I is 1 to 2 and expands j. So j is 4, 5, 6 and I is I. So I4, I5, I6. Now I goes from 1 to 2. So 1, 1, 1, 1, 4, 1, 5, 1, 6 and then 2, 4, 2, 5, 2, 6. So let us check. Well, another last question is there. E to the power x squared dx is a number, but 1 to 2 e to the power x squared dx is a function. So obviously the first one you can try easily, the 2j plus 1. So we just put j equal to 0, j equal to 1, 2, 3 and 4 and the answer would come 25. Often we do some problems in evaluating this kind of summation. So that's why this exercise is here. And the next one is also a similar kind of thing, but of course the answer is finally xj yj, not sum over xj and sum over yj. Some lot of extra terms will come in the answer given, but actually it is xj yj sum over j equal to 1 to s. And as I explained, the last part one is true. So if you expand, you will get the same answer. And here e to the power x squared dx is an indefinite, when not limit is there, no limit is there, so it gives a function. And on the right hand, e to the power x square 1 to 2, after all you putting the limit, you will get a number. So exactly the opposite is given in the question, so it's the false statement. In fact, the reverse is true. So let me go to the next slide. ln b by a is minus ln a by a. That is quite obvious. dy by dx is delta y by delta x for all functions of y. Again, dy by dx is delta y by delta x, but only for linear functions like y equal to mx plus c. The transpose of a column vector is a row vector. The matrix product BC of a row vector B times a column vector C is a scalar, both B and C having n number of elements. So you please take some time, check it, and then come back to the videos. Let me give you the questions. If the square matrix A has an inverse, if AB equal to AC matrices, then the matrices B and C must be equal. In ordinary algebra, it looks like that. If A is a square matrix of order n and C is a column vector with n elements, then AC is a column vector with n elements. So give pause, take time, do try on your own, and then come back to the video. But let me give you the answer now. The first one is true, as we know. The second one is false because it is really not valid for any arbitrary functions, but for linear functions it is of course valid. So the next question is true. The transpose of a column vector. So column means n number of row and single column. So n by 1, and if you transpose, then it would be 1 by n, that means a row. So the statement is true. BC, so 1 by n row into column n by 1. So 1 by n, n by 1, final matrix dimension would be 1 by 1. That's a single value. So it is a scalar quantity. Square matrix inverse, yes, but provided if and only the determinant of the matrix not equals to 0. Then only a square matrix may have some inverse. AB equal to AC, then B and C must be equal. No, it's false statement. In general, no. But only if A inverse exists, then of course B and C are same. A is a square matrix of order n and C is a column vector. So again you see square matrix, so n by n, and column vector n by 1. So the final dimension of the product matrix is n by 1, and which is a column vector, of course. So that statement is true. Well, this slide, a few questions are there. In fact, all the answers are true. So you please take it as home task or exercise kind of thing, because it is very preliminary matter of units, but that is some point of weakness of students. Often they do mistakes with the units. So please take it this slide as a home task and check it on your own. So thanks for watching. Our next video is going to be on general chemistry part 2, short answer type questions, SAQ. Session 2 is coming soon. Please keep on watching, do subscribe, and encourage your friends to subscribe and watch the video. Thank you very much.